Hello and welcome to this course on Kotlin Advanced Programming. As an aspiring developer, you may have some existing knowledge and skills in Android app development. This course will help you advance your app development level by introducing you to the finer points of Kotlin code and concepts. You will probably agree that there's an app for everything. However, it's important to realize that there isn't a great app for everything. The all-important metric of user experience is determined by excellent design coupled with solid software development. To achieve such excellence, it's vital to continually grow your mastery of the Kotlin programming language. In this Advanced Programming in Kotlin course, you will expand your Kotlin programming knowledge so that you can engineer better solutions when building Android apps. Kotlin is an open source language with an Apache 2 license and is available free of charge. It is used daily and worldwide by large and small organizations to produce many different types of apps. To do advanced app development work with Kotlin, you should have a good working knowledge of programming fundamentals, be familiar with the concepts of user experience and user interface design, and be able to create user interfaces in Android Studio. To assist with your learning, you will view and work on development tasks for the fictitious restaurant Little Lemon, where you will encounter many real-world scenarios. With your newly upskilled Kotlin knowledge, you will work through these scenarios, overcoming challenges and implementing solutions. As your skill set grows, you will focus on many Kotlin language tools, why you need them and how they are used. In this course introduction, you may encounter some new terms, but don't worry if you don't fully understand all of them. During the course, you'll explore these concepts in more detail, along with the core skills that are required during app development with Kotlin. This course consists of 4 weeks of learning. By the end of this course, you should have acquired the skills and knowledge with the necessary tools to complete the end-of-course Android project. Let's break down the content you will cover in each week of this Advanced Programming in Kotlin course. Week 1 covers the key features of Kotlin and Android and how they interact. After your studies this week, you will be able to explain how to use inheritance to decide how a component should behave, implement an application with an activity, implement a list adapter, and declare an object in Android. Create and use static inner classes and inner modifiers when appropriate, set and read activity arguments, and implement a companion object with constant values and arguments. Week 2 explores advanced object-oriented features. You will advance your skills during this week to be able to use an extension function to add a method to a class when appropriate, explain a testing methodology called test-driven development, list the main features of test-driven development, or TDD, and explain the purpose and types of testing. Use mocks and fakes for unit testing in Android, and define and use a generic class to solve a problem. Week 3 covers functional programming. You'll cover what it is and why it's useful. In addition, you'll work with functions in Kotlin. After successfully completing this week, you'll be able to explain what functional programming is and why it's useful. Read and define a function type. Use a Lambda expression to define a function as an object. And define a function that takes a function as an argument. Use collection processing functions to process collections in different ways, and use collection processing methods for multi-step collection processing. In this final week, you will complete a practical development task, which will synthesize the concepts and skills from this course to create a list with filtering and sorting in the final app development project, and allow you to reflect on the next steps in the learning journey. The Advanced Programming in Kotlin course introduces you to many software engineering concepts. These will help you to build a better Android app. Engineering excellence is not simply about what works well on the surface, but also about everything that is happening within. Your programming skills and approach to creating code solutions are the most important success factors when it comes to app development. I look forward to helping you build the advanced programming skills you need to get to the next level. Wishing you all the best on your Kotlin learning journey. Kotlin is a popular programming language used by Android developers. Kotlin is an open-source, full-featured development language that has a concise code syntax, and it integrates well with existing environments. There are many reasons that developers use Kotlin to build Android applications. These include Kotlin is concise compared to other programming languages. There is a large community of Kotlin programmers, meaning you can troubleshoot with other developers when you have problems. And Kotlin can run on multiple platforms. Kotlin is designed to run on Java Virtual Machine and can be run alongside Java. Kotlin is a preferred language for Android developers as it allows them to write more concise and safer code. Android Studio fully supports Kotlin. Many people typically access the web through their smartphones, and that means that almost all businesses must have a world-class online presence. Android is one of the most popular operating systems for mobile users, so even if Kotlin was only for Android development, Kotlin developers would be in high demand. However, it can be used for much more. Back-end development with Kotlin is among the most popular use cases of Kotlin. As the language is interoperable with Java, the existing projects on Java frameworks like Spring can be migrated to Kotlin gradually without a complete rewrite of the whole codebase. This makes the migration process less stressful and helps to prevent unexpected compatibility problems. In fact, many top-tier IT companies are already using Kotlin for back-end development for some of their projects. Web development with Kotlin is not limited to back-end development only, as Kotlin and JavaScript frameworks provide the ability to translate Kotlin code to JavaScript. This applies to the Kotlin standard library, any compatible dependencies, and your own Kotlin code. Therefore, Kotlin is powerful enough to be a first-choice technology for full-stack developers, since it supports building both back-end and front-end parts of web programs. Data scientists can also benefit from using Kotlin, as its syntax is readable and easier to learn than other languages. In addition, features such as static typing and null safety make the Kotlin code reliable and maintainable. As Kotlin is a JVM language, it can be used together with existing Java code and libraries, including popular tools such as Jupyter Notebook and Apache Zeppelin. Mobile development with Kotlin is not limited to Android only, as the Kotlin multi-platform framework enables you to write the core logic of the app for both Android and iOS applications. With this feature, you can build cross-platform mobile apps sharing common code between iOS and Android. Common code may also be used for web apps and libraries. While the main use cases of Kotlin are JVM-based technologies, it also supports native development. Kotlin native technology can compile Kotlin code to native binaries, which can be run on Linux, Windows, Android NDK, and on Apple systems such as macOS, iOS, tvOS, and more. Although a relatively new programming language, Kotlin already has a very large developer community thanks to being the recommended technology for Android. Meanwhile, the team behind Kotlin hopes to evolve it into a language that will be universally effective for development in any software or data science environment. When it comes to learning any new skill, like a new programming language, taking a moment to reflect on your progress is crucial. It's important to remind yourself of the milestones you've reached, practice the skills you've acquired, and revisit the knowledge you've gained. The purpose of this video is to allow you to do that, to reflect on and review your current knowledge and skills. Let's start with a general overview of what you have achieved from your study of Kotlin programming fundamentals. You began your Kotlin learning journey with an introduction that explored the basic programming concepts and data structures that are core to any language, while discovering the unique aspects that make Kotlin versatile and user-friendly. Then, to consolidate your understanding of Kotlin fundamentals, in the final project, you created a bank account simulator app where you implemented constants, variables, and operators to work with different data types, programmed loops and switch statements to create functionality based on varying conditions, and constructed functions to make your code reusable. Now, as you expand your understanding of advanced programming in Kotlin, your skill set will evolve further. Throughout this course, you will connect new knowledge of advanced programming with your existing experience and understanding of the programming fundamentals in Kotlin. Now for a brief review of what you should be aware of after completion of the fundamentals course. Let's recall the content of each week. Week 1 was Introduction to Programming, where you first identified the basic programming concepts that are core to the Kotlin language by describing basic types and variables, explaining numbers in Kotlin, and demonstrating the use of different types of operators, explaining what conditions are, and describing how to use loops. In Week 2, you covered functions, classes, and objects, discovering more about a function and how programs are constructed from functions, as well as how to use a class, object, and type while you are writing code. Specifically, you learned how to describe upcasting and downcasting, explain the open variable and methods and how to override them, explore the uses of interface, and describe class inheritance. Describe different scopes of access that a modifier can let the variable have. Explain different visibility modifiers. Explain the concept of a function and differentiate between a parameter and an argument. Explain that a function can return a value and describe how it works. Explain the difference between a class, an object, and a type, and distinguish between various visibility modifiers. Week 3 brought you to advanced classes, nullability, and collections. Here you learned more about advanced classes and objects in Kotlin. You also learned about list, set, and map and how these are used while writing code in Kotlin. You explored collections and when to use them. Specifically, you learned how to demonstrate the handling of nullability, describe nullable values, describe annotations, explore exceptions, describe the enum class and its uses, demonstrate how to iterate over enum class members, identify the pair and the triple, explain special kinds of classes, describe the use of collections in programming, identify which collection type to use in any given situation, and explain the difference between list, set, and map. The final Week 4 contained the graded assessment. By completing the items in this week, you incorporated all the skills you gained during the course to create code for the final development project. Your understanding of the programming fundamentals in Kotlin will serve you well in the coming weeks. You will have ample opportunity to integrate and exercise your existing knowledge and skill set with the advanced concepts introduced in this course. You've worked hard to get here. Keep going, stay motivated, and before you know it, you'll be one step closer to achieving your learning goals. When you program with Kotlin to create an Android app, you can write your code in an Integrated Development Environment, or IDE, called Android Studio. Android Studio is an IDE dedicated to Android development. Android Studio fully supports Kotlin. You can add Kotlin files to projects and use the tools of Android Studio to aid your development. Features of the Android Studio IDE include autocomplete, lint checking, debugging and testing, refactoring, and publishing. To start building Android apps using Kotlin, you need to download Android Studio, install it along with its development tools, and then use Android Studio to create a new project. First, let's get the download. In your browser, go to developer.android.com/studio. The Android Studio website can determine the optimal download options to match your computer system. So in most cases, you can just click on the Download Android Studio button. Accept the terms and select your machine's configuration, Mac with Intel or M1 chip. And when the download is finished, open the installation file. Once downloaded, you can proceed to do the installation of Android Studio. To begin the install, you need to drag and drop Android Studio to the Applications folder. Now you can open it from the Apps list. If you do not have a previously installed version of Android Studio, there is no need to import settings. You can agree to or decline to send crash reports. After the welcome screen, you are then prompted to select the install type. Standard settings are fine to start with. You can always customize them in the Studio preferences. Next, select which style you prefer, light or dark theme. The next screen summarizes the additional Tools and Software Development Toolkit, or SDK, to download. For the download to start, you need to accept the license agreement. After accepting the agreement, wait for the SDK and tools to be downloaded. Once that finishes, Android Studio is now installed and configured. You are now good to go and you can start your first Android Studio project. Now let's check how to get started with an Android Studio project. After a successful installation and each time you start the IDE Android Studio, a welcome screen invites you to create a new project or import an existing project. Let's proceed with a new project, and then you will get an offer of multiple activity options to include in the project. These options will include ready source code for implementing selected features. For example, you can choose login activity, and Android Studio will provide the source code for basic login functionality, such as username and password fields, login button, and so on. You do not have to select any activity options. However, typically, there is at least one activity in every Android project. Therefore, let's proceed with the empty activity. This option will produce a minimal amount of code for an activity creation. As a result, it may prove to be less distracting as you build your own code. On the next screen, you enter the name of your project, for example, Little Lemon Shopping App. The package name will be a unique prefix for files in your project. Usually, it includes domain, company, and project names. For example, com.littlelemon.shoppingapp. Next, select a save location for the project folder. The language chosen by Android Studio is Kotlin by default. That is exactly what you want, so there is no need to change it. The minimum SDK defines which Android versions will be supported by your app. As the current default version is 5.0 Lollipop, devices with older Android versions like 4.2 KitKat will not be able to install this app. As stated on the installation screen, 98.8% of Android devices have Android 5.0 or a higher version, so it's a good place to start. You can always select a lower minimum SDK, but bear in mind that it may introduce limitations on the tools and libraries that you can use for development. Once you complete the selection of the SDK, your first Android Studio project is created. In summary, what you need to do to begin your app development is download Android Studio, install and configure it, and set up a project. You can then begin to program with Kotlin and use all the Android Studio features to help you create an app. Previously, you learned how to create multiple instances of a class. In this lesson, you will learn about singleton, which is an approach that can create only one instance of a class. A singleton can be described as an object-oriented pattern where a class can have only one object at a time. The previous examples you worked on were able to create multiple instances. A strength of the singleton pattern is that it does not allow multiple instances. By declaring a singleton using object declaration, you guarantee that you will only have one instance that can access a class. This is a way of controlling access to a resource. It prevents conflicts that occur due to multiple instances of access. To expand on the previous definition, a singleton can be described as an object-oriented pattern where a class can have only one object, that is, an instance of the class at a time. Let us say you have a list of customers for the Little Lemon restaurant. To store this data, you create a class that allows you to add a customer, delete a customer, or print all customer information. In addition, you want that list and all related methods to be accessible anywhere in the app. You can solve this problem by using a singleton. As an example of how this works in practical terms, say you have a data class called customer. The class called restaurant tables is created, and within this class, it has a list of customers and three methods: add customer, delete customer, and print all customers. In the main function of the program, two instances will be created. The purpose of having two instances is to simulate the multiple access of a class. A new customer is then added to the customer list by calling the addACustomer method, which is accessed by instance 1. Despite the two instances having access to the same class, Instance 2's customers list has not changed when a new customer is added to Instance 1. This would be considered a data conflict, and that is a problem. When you have multiple instances of a class and you want the changes that may occur to be accessible anywhere, the normal class or ability to make multiple instances that can access a class is not useful. In this case, there should be only one instance responsible for access. Using a singleton guarantees that you only have one instance to access a class. In this example, a singleton can be declared using object declaration. That can be done by making some modifications to the restaurant table class. Instead of using the class keyword, use the object keyword and remove the parentheses. The object, or the singleton in this instance, cannot be instantiated. Multiple objects of the singleton cannot be instantiated. With an object specifically, we access the functions directly without having an instance. You can call the object directly as restaurant table, and then you can make any changes, such as adding a new customer. The restaurant table object can be used in different scopes of code. Therefore, if a new customer is added which updates the list of customers, the object will have the same value in all scopes where it is in use. Let's summarize the key points you learned in this video. A singleton means you only have one instance to access a class. To do this in Kotlin, you can use an object declaration. To declare an object, use an object keyword followed by the object name without parentheses. And inside its curly braces, you can add methods and variables that are to be accessible using that object anywhere. In the singleton pattern, the constructor must be private. In Kotlin, you can use an object declaration to implement the singleton pattern. If you try to create a constructor, the compiler will display an error. In addition, if you try to instantiate an instance for an object, the compiler shows an error as it's only one instance. When you need to access the singleton, you can call it by its qualifier or name followed by any created method member or variable that you want to access. Lastly, the singleton pattern is most useful in real-world projects when you need to create a program that only needs one instance to have access. You should now know about singletons, what an object declaration is, and how to use them. Earlier, you learned about creating a class in Android Studio. Declaring and working with a singleton object is very similar to that process. The word object is also used to describe the class instance. To avoid confusion, I'll use singleton object while referring to the Kotlin language implementation of a singleton pattern. To create a singleton object, right-click on the package, select New, and choose the Kotlin class or file option. A pop-up window offers multiple options to select. Choose the last item, Object, and enter Restaurant Tables into the name field. As you maybe already guessed, you'll implement the Restaurant Tables feature from a previous video. What you have done so far is called an object declaration and declared the Restaurant Tables object. That is to say, you created a singleton object named Restaurant Tables. Like in a regular class, everything that you write in the curly braces will make up the singleton's body. Similarly, in a singleton's body, you can declare variables and functions. Let's add a variable that will represent the list of customers. Val customers, : and the type. For simplicity, only the customer name will be stored. You will need to add or remove customers. A regular list does not allow you to add or remove elements, therefore the variable type will be mutable list of string. Mutable list, angle brackets, and string. The customer's list will be empty when created, so type in mutable list of as a variable value. Mutable list of creates an empty mutable list. And then let's create several functions that will add or remove items in the customer list. Function add customer, you need to pass the customer when executing this function, so it will have a parameter customer of type string. Inside the curly braces, that is in the function body, enter customers add customer. The add customer function is ready. Let's add a remove operation. Fun remove customer. Similarly, you need to pass the customer to remove customer string. In this function's body, enter customers remove customer. Now let's try to access this variable from outside the class. Open main activity and inside the onCreate function, type in the singleton's name, Restaurant Tables. As you already know, you don't need to instantiate it, so there is no need for parentheses. Restaurant tables .add customer and pass customer name, double quotes, John. Let's add two more customers in the same manner. Add customer Lisa, add customer Alex. Similarly, you can access restaurant tables from the second activity and execute remove customer there, remove customer John. Note that the customers field in restaurant tables is modified from both classes and they share the same data and we have no conflict. Like a regular class, a singleton object can be inherited from another class or interface. Let's create a personnel interface and inherit several singleton objects from it. The interface will have a function named serveCustomer, fun serveCustomer and parenthesis. Now let's declare an object, manager. Usually, there is only one manager in a store, so this is a perfect example of a situation where a singleton object could be used. Create an object named manager. Now have it implement the personnel interface. Enter : after its name and personnel. You have to implement the interface's function, serveCustomer. To summarize this demonstration, object declaration is very similar to declaring regular classes. You learned how you can practically create an object and use it, as well as implementing an interface in it. This will help you to effectively use Kotlin for tasks that require a single instance of a class to be used in multiple parts of your code. In this video, you will learn how to create and use companion objects in your Kotlin code. Companion objects are used in Kotlin to store static data or to provide static methods. When a programmer refers to static, they mean data that remains the same would be immutable. Static means there is a single instance. An object is static. It does not mean an object has to remain the same, because an object can be mutable. Static is a well-known concept across other widely used programming languages like Java and C#. It is often helpful to have methods or parameters that are common across all instances of the class. Objects, as mentioned earlier, are static. In addition, we have companion objects. In order to achieve the features of the static class, Kotlin companion objects are essentially just one or more static fields or methods declared inside a class. You use a companion object if you want some implementation to be a class, but still want to implement some behavior as static behavior. These are object declarations inside a class. These companion objects are initialized when the containing class is resolved. In Kotlin, a companion object is an object that is associated with a class. A class can only have one companion object. Companion objects can be used to store static members of a class or to provide factory methods for creating instances of the class. Let's take a look at this in practice. In previous videos, you learned that sometimes it is necessary to have a single instance of a class in the whole program. A singleton pattern enables this, and in the Kotlin programming language, this pattern can be implemented using an object declaration. This is a rare case scenario. Most classes in your program will need to have multiple instances. However, you may need some parts of your class to be the same in all instances. The concept of static is exactly what you need for such a scenario. Kotlin does not have classic static syntax, as in some other languages, where you can just use something like a static keyword in variable or method declarations. Instead, in Kotlin, static is implemented using companion object concept. Companion is a static part of a class, which means that all functions and variables inside its body will be the same when called from different classes. Let's continue the implementation of personnel classes and practice with companion objects. Create a new class named Waiter, which implements the personnel interface. Android Studio requires us to implement its methods. Let's do it. Override fun, serve customer, and curly braces. Each waiter may have an ID and name, so let's add these properties. Insert them in the beginning of the class. That's the recommended code style. Variable ID of type int initially will be equal to -1. Variable name of type string. Initially, its value will be an empty string, so just double quotes. Little Lemon Restaurant has several waiters. However, it has only one branch. Therefore, the branch name for each waiter should be the same. This is a good use case for a companion object. Let's create a companion object for the waiter class. After the server customer function body, that is to say outside its parenthesis, enter companion object registration. Companion is usually located in the bottom of a class. This is a coding convention. In the body of companion, add new variables, branch name and branch address, both of type string. Variable branch name : string equals double quotes. Now let's access this companion from main activity, waiter.registration.branch_name. Let's set the value as Little Lemon main branch. Similarly, you can set the address, waiter.registration.branch_address equals New York, 5th Avenue, 25. Android Studio is suggesting removing registration from these references, as the companion name here is redundant. You still can access the branch name and branch address. The reason is that each class can have only one companion, and therefore naming it is not necessary. You can still name it if you like, however, this is not a common practice. Therefore, let's remove its name from the class as well. Navigate to the waiter class and remove registration. Now, all instances of the waiter class will have the same branch name and address. If it changes in the future, you can just access the static variables of waiter class and update them. This will update them for all instances of waiter class. To summarize my demonstration of companion objects, remember that a companion object is a powerful feature of Kotlin, which enables static variables and functions. Unlike other programming languages, it allows you to visually separate static members from the non-static ones. You will use a companion object a lot in practical Android development. Therefore, it is important to remember and follow code convention guidelines. This will make your code more readable and intuitive. In this tutorial, you learned about the concept of companion objects in Kotlin. These are used to provide static behavior to parameters or methods defined as part of the companion object. You may have observed that when you enter your username and password in an app and press the login button, it takes you to its home screen. Or when you click on one of the items, say in a list of movies, the app takes you to another screen that plays the movie. In Android, one way to implement such screens or app sections is by using activities. And in this video, you will learn how to move from an existing activity and start another activity. Let's say you have two activities in your family restaurant app, Little Lemon. The first activity contains a list of food items that a customer can add to their cart. This activity also contains a button, clicking on which the app will take you to the second activity, which displays the list of items that the customer has shortlisted and added to the cart to place in the final order. Those are two separate activities, and you will learn how to start an activity and move from the first activity to the second one. But before that, let's have a brief look at how to create activities. In the navigation pane on the left, find your project's folder that contains all the source code files. Right-click on that folder and select New Activity. This will show a list of different types of activity templates that can be readily used. For this video, simply select Empty Activity. Enter the desired activity name and click Finish. Now coming back to the earlier scenario, let's call the activity containing the list of food items that can be ordered as Food Item List Activity, and the second activity that shows the items present in the customer's cart as Cart Activity. Let's say a button is present in the Food Item List activity that when clicked on, the app takes you to the Cart activity. Let's assume that this button is stored in a variable called ShowCartButton. Let's first define a click listener that will execute whenever the button is clicked. This will later contain code that will start the Cart activity. Now, to start the cart activity, you will need to use something called an intent. Intent is a special class in Android that helps communicate between several different components in an Android application. As of this video, you will stick to the scope of communicating between activities and specifically starting an activity from another. In Food Item List activity, to declare an intent inside ShowCartButton's click listener, create a variable called intent and initialize it. Let's examine the different parts of this. You create an instance of class intent and pass to it two arguments. The first argument, this keyword, refers to the current activity's instance, which in this case is Food Items List activity. This activity is a type of context that tells the intent which application is creating the intent. This is important as intents can be created from one application with its destination as another application. For example, an app may want to access images stored in the gallery app. The second argument, cart activity : class.java, refers to the destination activities class that needs to be started. Note carefully that .java is suffixed with the activities class because it returns Java's class equivalent for the Kotlin class. Cart activity : class. To start the cart activity, call startActivity function that is readily available in the activity class and pass the intent as an argument. This will launch the cart activity. And that is a brief demonstration of how to launch an activity. You have already learned how to start an activity from another activity by using the startActivity method. In this video, you will learn about sending data from one activity to another. Sending data between activities is a beneficial feature when developing applications. To demonstrate the benefits, let's consider a simple user interface or UI. It is in the main activity and has one button and some text. Then you can create a new activity called Second Activity that only contains a greeting message used to display the text data that you are going to send from the former activity while calling the second activity. In the button's onClick event on the main activity, declare a new variable of type intent. Then initialize the intent by passing in the current activity, which is the main activity using this keyword, and the destination's activity class, secondActivity.class.java, as the two parameters. The intent class has a number of methods to send data from one activity to another. For example, to send a string, you can use a method named putExtra and pass to it a string key and a value. The key will be used by the second activity to identify and receive the data passed as value. Let's define an arbitrary key, MSG, and a value called hello from the main activity that you want to send as. You can start the second activity by using the start activity method. To receive the value in the second activity, you can use declared intent in the parent class. The declared intent ensures that your second activity can receive the value of MSG from the main activity. To summarize, you'll use intent and get string extra within its parenthesis, and you need to pass the key of the values, which is MSG in this example. To avoid misspelling or writing in the wrong case, it's recommended to use a companion object in the activity to direct where to send your data. In this companion object, you declare constants for keys as strings. In the receiver activity, you need to call the sender activity name followed by the constant name that you want to use. To do that, let's adjust the example. First, let's declare a companion object in the main activity, starting with two constants. One is called value1 as string with a value of 1. The second is called value2 as string and its value is 2. Then, instead of using the key directly, let's use the declared constant with extra methods that you use to send the two numbers to the second activity. In the second activity, let's use the main activity class name followed by the constants. If you run the code, everything will be working correctly. You now know what activities with arguments are, how to use, set and read activity arguments. You also learned how to send and receive data between activities. Well done! You've reached the end of this week, and it was all about Kotlin and Android. Let's take a few moments to review what you've learned. The major new learning area for you in week 1 concerned object declarations. You specifically learned about object declarations in Android, as well as constant values in Android and activities with arguments. You discovered the concept called singleton, where you create only one instance of a class. To do this in Kotlin, you use an object declaration. To declare an object, use an object keyword followed by the object name without parentheses. By declaring a singleton using object declaration, you guarantee that you will have only one instance that can access a class. You then covered defining and using companion objects, used in Kotlin to store static data or to provide static methods. You then learned how to use constant values in Android, allowing you to create an item with multiple options which users can choose from. Then you learned how to move from an existing activity and start another activity, showing how you move from one page to another, such as a login page to the home screen upon entering a username and password. And finally, you learned how to implement constant values and functions with arguments in companion objects, completing the main portion of this lesson. That's the end of your study for this week, where you covered many new areas of advanced programming in Kotlin and Android. Well done. Looking forward to studying some more new skills and concepts with you next week. In this video, you will learn about extension functions and how they can help you in extending functionalities of a class or an interface you cannot inherit or modify. A concept you will have learned about in previous courses is inheritance. Through inheritance, you can extend or modify certain characteristics and behavior of subclasses in code, while reusing functionalities from the parent class wherever needed. Let's say a car company manufactures two different variants of the same car model, one called the base variant and another called the luxury variant, which has premium leather seats, alloy wheels and a professional music system, all offered on top of the base variant. The luxury variant represents inheritance. In this example, the manufacturer extends the features of the base variant to build the luxury variant. However, there is a common issue with the concept of function inheritance. Let's say you wish to buy the luxury variant, but also add some additional features that the auto company does not provide. If we compare this example with what happens in code, you assume the luxury variant to be a class. In this code example, the luxury variant is not possible, as the car company is an external entity and would not allow you to directly modify the car during its manufacturing and assembling process. So inheritance is not possible. This is where extension functions come to the rescue. Whenever you need to extend the functionalities of a class or an interface in an external or a third-party library that you cannot inherit from or modify, you use extension functions. These new functions are called in the same way as any function, just as if they were functions of the original class. Now, let's say the luxury variant has 6 music speakers, but you wish to add 4 more music speakers to improve its sound quality. Assuming you would have a class with a variable that stores the number of speakers in a variable, you would then have an extension function that shows the 4 added speakers. So now this code will print the number of speakers before and after adding the additional 4 speakers to the luxury car variant. It will initially print 6 and then in the second line it will print 10. Now let's discuss the limitations of extension functions. Extension functions do not allow you to modify the behavior of classes they are defined for. They only provide an alternate syntax that allows the functions to be called using the dot notation with the type for which the function is defined. For instance, for the class luxury car, a function named getSpeakerCount for luxury car that returns the speaker count and takes in the object of the car as a parameter can be rewritten as an extension function for the type luxury car as luxurycar.getSpeakerCount. Also, you cannot access the private members of a class, as these functions are generally defined outside the class. So, let's say in the previous example, we add the private visibility modifier to the variable speakerCount and try to run it again. It will result in an error showing that speakerCount is private in luxury car. Another limitation of extension functions is that they are resolved statically. Let's look at what that means. Say you have a class called baseCar that represents the base variant. It is marked with open keywords that allow it to be inherited. Another class, luxuryCar, inherits this class. Both the classes define a function called getSpeakerCount that returns the number of music speakers that the variant has. Now, if you define a function printSpeakerCount with a parameter of parent type baseCar that prints its speaker count and call it using an object of type luxuryCar, it will print 2 instead of 6. This is because extension functions get invoked on the declared type, which in this case was the parameter of type baseCar. Moreover, if a class defines a member function with the same name as an extension function, the member function always takes precedence over the extension function. For instance, let's say the class luxuryCar defines a function that prints the color of the car, and there's an extension function with the same name. When invoked, the function defined in the class is called and the extension function is not executed. Therefore, this prints black as the car's color. In this video, you learned what extension functions are, why you need them, and what their limitations are. Later, you will learn how to define and use extension functions in your code.
Module 2, Lesson 1, Item 2, Extension Functions in Android. The extension function is a powerful feature of Kotlin because it allows you to add extra functionality to an existing class, even if you don't have any access to its source code. In this video, you will cover how to define the extension function in Android and explore how to use it. Let's start with an example. In the Little Lemon food ordering app, you want to display information and news updates to the user. This might contain messages such as, "We now roast our own coffee beans daily." Toast is an important widget in Android that lets you display such a floating message in front of the user. To create the news update, you just need to use the Toast class and use the makeText method, passing to it all the required arguments as the context, the text that you want to be displayed, and the duration that it will be visible in front of the user. Then enable its display by using the show method. So, using the Toast, you build the Little Lemon news update about coffee beans. Now, you want to issue an update about a special offer. To use the Toast you just created, you will normally have to repeat the same steps each time you want to reuse it. Thankfully, there is another way. You can create an extension function, and that function can be reused in any of the application's activities, such as second message to the customers. To achieve this, first create a new file called extension helper. And the purpose of creating a new file is to keep the code separated so that your project is better organized. Then remove all code that is created, since you don't need to have a class name here, you just need an empty file. Next, use the fun keyword followed by component activity, as we want to use the toast with any activity. Then add your method name. In this example, it is called showMessage, and it has one parameter called text as string. This is the text that you want to be displayed. Within the method body, create the toast and pass the required arguments to the makeText method. And then execute show function. Finally, in the onCreate method, you can call that method showMessage and pass the required text. Run the code and the toast pops up. Now, let's create one more activity named second activity. In its onCreate method, we can execute the same showMessage function and pass hello from the second activity. As you see, we did not create a showMessage function here, nor did we call toast makeText. As component activity is a parent of second activity, we can reuse its extension function here. For any activity in your application, you can call that method to display a message without having to repeat the same code. That's a great advantage of using an extension function. Let's try another example. Let's build a shopping feature for the Little Lemon application. There is a list of product objects with title and amount variables, and the app should display the title of the product and the amount of item in parentheses. This is how much stock of the item is available in the warehouse. If the amount is equal to 0, then text out of stock is displayed. This can be achieved by creating an extension function for an integer class. I'll call it getFormatedAmount. Inside, I check if amount variable is more than 0. The this keyword here refers to the amount variable. I return the number itself as a string. Else, I return the text out of stock. Now, I can display each product in a single text view by creating a loop that iterates through the products list and sets the text. Let's run the code. Great. The app displays the last product and its amount. However, the rest of the products are absent, as text view setText replaces the previously setText. You can fix this problem by creating one more extension function for text view, named appendText. This function will receive a string and combine it with existing text from text view. Let's run the code. Now all products and their availability are placed on the screen one after another. In summary, you learned how to define the extension function in Android by using the fun keyword followed by the class that you need to add a method to. In addition, you explored how helpful extension functions can be to solve real problems in Android development.
When you're building something, you want to make sure it works. The way to be sure that it works is by testing it, right? That's why testing is an essential part of software development. It is the quality assurance component that ensures your software works as expected. In this video, you will explore the purpose of testing in a software development environment. Testing helps prevent many problems such as code errors and compatibility with devices. Identifying issues at the testing phase leads to a better product, and that means a better experience for end users. Let's say you develop an app for the Little Lemon restaurant for their takeout food. Soon orders start coming in. It's a great start and traffic increases each day. However, with this increased volume of transactions, your app starts displaying errors and stops working. You lose out on many sales and the reputation of your app is affected. You may have faced such situations where software applications fail, process requests incorrectly, or even crash completely. To avoid such scenarios, it's important to test the software application beforehand and ensure that the code executes as expected in all possible conditions. But what exactly is software testing? Software testing is the process of evaluating, validating, and verifying a software application and its components. Testing is based on correctness, reliability, performance, and completeness. One aim of testing is to identify issues or defects early in the development process before an error becomes entrenched in the code. Originally, testing was performed in the later stages of the software development lifecycle, just before the software application was rolled out to end users. As software applications grew in size and complexity, testing evolved to be integrated earlier and at all stages of the development process. Several different testing types were created to deal with emerging requirements, such as unit testing, integration testing, end-to-end testing, performance testing, and acceptance testing. The efficiency of any testing type is dependent on how well written it is and how many types of defects it can detect. I'll cover some of these in detail in a later video. With adoption rates continuing to rise for all types of digital solutions, customer experience has become vital. Unreliable applications lead to a poor customer experience and cause end users to abandon the app for other alternatives. Testing helps to increase user retention because it can find performance issues, detect security vulnerabilities, highlight poor design, address scalability concerns, and ensure reliability to end users and stakeholders. There are certain practices that should be followed to effectively test software applications. These include the code being tested should allow for the reusability of tests so that the same tests can be used and run repeatedly whenever needed. Tests should be written or performed with an awareness of the requirement specifications of the software application to guarantee that the software application correctly implements its functionality as desired. Individual tests should run and pass in isolation as well as when they run along with other tests. There are different approaches to testing, but often the testing life cycle consists of the following steps: analysing software requirements, test planning, designing and developing test cases, preparing the test environment, executing the test, and reporting issues and defects. You may be familiar with the phrase test case, but what is a test case? In software testing, a test case has a particular meaning. It is a set of actions performed on a software application or its components to validate and verify the behaviour of the software under test. A test case consists of data, steps, preconditions and expected outputs that verify the software application's correct implementation of its required behaviour. A test case aims to verify functionality and find defects. A well-written test case is generally reusable, guarantees reliability, ensures software behaviour, provides a better user experience, and reduces costs. As software applications keep expanding in size and complexity, several testing types and categories along with different tools and products have evolved to best meet the requirements of the software application under test. For instance, a banking mobile app will have different testing needs than a food delivery mobile app. The different types of testing are covered in another video. While testing is important, it is also essential to know when to stop testing. No software application can ever be completely free of defects. The way to determine a stopping point is to establish a few metrics. These include the number of test cycles executed, the percentage of successful test cases, time intervals between test failures, and the monitoring of test result trends. In this video, you learned about testing. Remember that when you're building an app, you want to make sure it works, and the only way to check that is by testing it. Experienced developers test their code early in the development process and then test frequently throughout the development cycle. The type of testing and the product used for testing depend on where your code is in that cycle and on what you are testing for. For instance, a test for code errors may differ from a test for device compatibility. Testing leads to locating and removing problems, and that results in a better app with a better end-user experience. Software applications continue to grow in size and complexity. Each application has its own testing needs, and this has resulted in many testing types to choose from. The question is, what type of testing should you use for your applications? In this video, you'll learn about different testing types and how to decide on a solution for your workflow. Software testing is generally classified into two categories: functional testing and non-functional testing. Functional testing deals with testing the functional aspects of a software application. It aims at validating and verifying the correctness and completeness of a software application. These tests can either be run manually or using automation tools. Non-functional testing deals with testing software applications in terms of non-functional aspects such as reliability, scaling, performance, security, and so forth. Non-functional testing assesses application properties that aren't critical to functionality but contribute to the end-user experience. Generally, non-functional testing is done after functional testing and is usually completed using automation tools. In this video, you will learn more about functional test types that can be written in code to verify code behavior. These are known as unit testing, integration testing, and end-to-end testing. Unit testing is the most common kind of testing where individual units or components of a software application are tested. The small part of code that is being tested is called unit under test. This type of testing aims to verify the correctness of small functionalities in code, such as that of objects, functions, modules, and so forth. The general practice of writing a good unit test involves three parts: arrange, act, and assert. The first step, arrange, suggests that you should arrange data and initialize the objects required to be fed as input into the functionality under test. The second step, act, performs an action by executing the functionality under test while passing the data arranged in the first step. The last and final step, Assert verifies and asserts that the data received as output by executing the functionality under test in the second step matches the expected output of the test. If the data matches, then the test has successfully passed. Otherwise, the test fails. Let's say you develop a calculator application and wish to unit test your code. In that case, you would run unit tests to verify functions such as addition, subtraction, multiplication, and so forth. Integration testing is aimed at testing whether different modules or services are working properly with each other. Take the case of the food delivery app for the Little Lemon takeout business. An example of integration testing is to test whether the delivery service provider integrates and works correctly with the payment service. Compared to unit tests, integration tests are generally more expensive to run, since they require several parts of software applications to be working together. The final functional test type to explore is called an end-to-end test. End-to-end testing is a testing methodology that consists of testing a software application's workflow from the start to the end by emulating a real-world scenario. This type of test replicates user interactions and behavior with the software application to test the application behavior and verify whether the actual output matches the expected output. In the food delivery app for the Little Lemon restaurant, an end-to-end test may consist of mimicking user interactions with the app. That could include a search for items that can be delivered, shortlisting the list of items to be delivered, entering payment details, processing the details, and finally placing the order. End-to-end testing is very useful, but it is a far more expensive test to run than unit or integration testing. In addition, they are harder to maintain since software application requirements often change, causing a redesign of the test. An approach often taken is to test crucial flows end-to-end and rely more on integration and unit tests since end-to-end tests are generally slower to run. In functional testing, the use of different test types tends to follow a pattern of being mainly unit testing, then integration testing, and then a lesser proportion of end-to-end testing. That reflects the fact that some testing techniques are more expensive and slower to run, while others are cheaper and faster to run. In this video, you learned about types of testing. Your first decision on testing is whether to use functional testing or non-functional testing. Functional testing deals with testing the functional aspects. Functional testing is responsible for verifying whether a software application meets its specified requirements. Non-functional testing deals with testing non-functional aspects such as performance, reliability, and security. Generally, non-functional testing is done after functional testing. The functional test types are categorized as unit testing, integration testing, and end-to-end testing. It's important to appreciate that the purpose of these testing methods is to build a systematic approach for testing and identifying faults and improvements as early as possible. The result is improved app performance and experience. At this point in the course, you should already know what unit tests are and why they are important. In this video, you will learn how to write a unit test for a Kotlin class. The class I'll be writing a unit test for is created to help Little Lemon calculate the price of 2 food items. A successful conclusion of the test will confirm for us that the class works as expected. The test I will write is for the class Price Calculator. It is a simple class with a single function, calculate price. This function takes the prices of 2 food items before tax and a sales tax rate as input. It then returns the final price of the items. Android Studio makes creating a unit test as easy as possible. I right-click on the class name, Price Calculator, to open a context menu. I hover over Go To expand the submenu, and then I click on Test. In the menu that opened, I click on Create New Test. This opens the dialog for creating a new test for our class. From the Testing Library drop-down, I select JUnit. JUnit is a simple framework for writing tests. Android Studio creates new projects with the JUnit 4 support built in, so this will make things easier. To generate the unit testing template, I click OK. I select the test folder to save the file. Android Studio has created a file for our unit test. You are now ready to start writing our first unit test. I start by declaring a field for my class under the test instance. This is a conventional name for the class being unit tested. Right under the class declaration, I type private val, class under test equals price calculator. The private modifier is there so that I don't expose anything that is internal to this class. I name the field class under test and I assign it to an instance of price calculator, which is the class I am testing. I am now ready to write the first test. Each test is a function inside the price calculator test class. I can name my test function anything I want. I will take advantage of Kotlin allowing me to have spaces in function names by enclosing the name in backticks, and right after the class under test field declaration, we'll type fun validate calculation. For JUnit and Android Studio to recognize my test, I need to annotate my test with @test. I type the annotation right before the function declaration. It is highlighted in red because Android Studio doesn't recognize it. I hover the mouse cursor over the @test annotation. A window appears saying Unresolved Reference Test. I click on Import to import org.junit.test. A green arrow appears to the left of the price calculator test class declaration and to the left of my test function declaration. These arrows allow me to run all tests and the specific test declared in the function correspondingly. To quickly trial my test class, I click on the green arrow to the left of the price calculator test class declaration. I then click on Run Price Calculator Test. On the bottom left are the results of the tests. Since our test doesn't throw any exceptions, it passes. I now add a call to calculate price with the price of 2 items and a tax rate. I store the output in result. I know the result should be 960. To validate the result expected, I add an assertion, assert equals. Because I am working with decimals, 0.001 is the acceptable error margin. I click on the green arrow again to run the test. On the bottom left, the results display. The test passes. In this video, you learned how to validate your Kotlin class works as expected by writing a unit test. Unit tests are a powerful tool for ensuring your code works as expected. Having a successful unit test of a price calculator gives the Little Lemon restaurant greater confidence that they are charging their customers the right amount. Creating software is a time-sensitive activity, which can mean that development work often gets priority. That way, you hit your development deadlines, but testing is delayed until the end or toward the end of the software development lifecycle. This is not the ideal approach. It may not leave enough time for testing to be conducted effectively and can result in software bugs or a less than optimum product. In this video, you will explore a testing methodology that takes a different approach. It's called Test-Driven Development, or TDD, and you'll discover how it applies to software testing. Rather than leave testing until the end of your project, Test-Driven Development, or TDD, is an alternative testing methodology in which the tests are written first and the code is written later. In this way, the software is developed so that it will pass the tests. TDD is an iterative testing system that usually involves a number of steps. These steps are: identify and plan for the software features and requirements, write tests for different execution scenarios, write and implement code to fulfill the features and requirements in step 1 with the intent of passing the predefined tests, run the tests, evaluate any errors and refactor the code as needed, and rerun the process until all tests are passed. This process is also called the red-green refactor cycle. Red indicates the failed tests. Green, on the other hand, represents the passing tests. Refactor represents the final tweaks to the code that don't change implementation details, which can always be confirmed by running another test. When following the red-green refactor cycle, the intent is to fail the tests and rewrite the code to fix the causes of failure. Therefore, a feature is complete when all the tests are passed. TDD focuses on simplicity and achieves this by testing small units of software requirements. Writing tests first encourages developers to think through the code design beforehand. Just think how TDD would operate in a real-life situation where you have a task to perform. Let's say the task is driving to work. You leave your desk and walk to your vehicle. You go to open the door, but discover that you don't have your car keys with you. Of course, you say, I left them on my desk. That's not an uncommon occurrence. Now, if you followed a TDD approach, you would do things differently. First, you check or test if you have your keys with you. Your test fails because you don't have them. They're on your desk. You perform the action of getting your keys from the desk. Finally, you check or test if you have your keys. This time you do have them, so your test now passes. There are several advantages of TDD. You write minimal code with the intent of passing all the defined tests. This is effective, given the tests are holistic in nature. Your code is highly tested and has high test coverage as you only write code to allow the test to pass. It is easier to maintain and refactor code in the future without the fear of breaking something in your software application. The tests serve as documentation for the code and depict how the code should behave. The code becomes modular as you write tests for testing small pieces of functionalities, then develop the code for them and iterate on this process until the required implementation is complete. When implemented correctly, TDD brings huge benefits to a software development project. However, there are certain dangers with TDD, such as writing tests alone is not sufficient. It is vital that tests correctly map with the specified requirements. When a test does not represent the correct expected behavior from the code, the purpose of that test is invalid. Following TDD strictly can potentially lead to an excessive duration spent writing and running tests. Developers may incorrectly assume expected outcomes or lack understanding of the requirements. This can lead to tests passing, but they are a false positive. Following TDD can feel overwhelming and is a slow process. Often, developers find it hard to adapt to it as a practice. Test-driven development, or TDD, is a technique that helps achieve greater quality when building software applications, and it provides early feedback about the operation of the application and its components. In this video, you learned how test-driven development works. You also covered the steps involved in the TDD approach and examined the implementation of the red-green refactor cycle. You're spending a lot of time studying and practicing your software development. Let's say you're planning to take a break and watch a movie at a nearby cinema. In this case, you would generally search for the movie you're interested in watching and then filter the show listings based on your time preferences. Then, let's say you decide to buy 2 adult tickets and 1 child ticket. If you observe carefully, you will realize that you performed various operations on different collections and their elements. For example, for a given movie, to select a show, you filter the list of available shows based on your show timing preferences. Once a show is selected and the tickets are added to a cart, the system calculates the total amount by executing a sum operation on all the elements of a collection that represents the list of tickets. Similarly, you would generally come across several scenarios in your daily life when certain operations on elements of a collection are applied. In this video, you're going to learn about the idea behind collection processing, explore a few examples of collection processing, and examine the steps involved in it. Firstly, let's address what collection processing is. Collection processing refers to applying certain operations on some or all the elements in a collection. Let's say you are analyzing the order history of the restaurant Little Lemon for the past week. You have a collection with each element as a list of orders for a specific day. Now, let's say you wish to have a look at the orders for Wednesday. You would apply a filter operation to the collection with its value set as Wednesday. Now that you have the list of orders for Wednesday, let's say you wish to apply a sorting operation so that you can see the list of orders in the descending order of the order amount. For this, you would apply the sort descending operation on the collection of orders. Lastly, let's say you wish to calculate the total amount of all the orders that were placed on that day. For this, you'd run an operation that would aggregate and sum the amount of each order to return the total amount. That's an example of collections in action. You just implemented 3 different operations on collections. You applied a filter operation to filter the list of orders by a specific day, followed by a sort descending operation to arrange the orders in the descending order of order amount, and then finally a sum operation to calculate the total amount of orders on that day. A few other common examples of collection processing include sorting courier deliveries based on postal or zip code, finding the average of a list of numbers, grouping together a list of sub-items to form another list, splitting a list of numbers into 2 lists, one for odd numbers and another for even numbers. Collection processing involves 3 primary steps: accessing elements of a collection on which the operation is to be applied, defining and applying the operation on the element, and outputting a modified collection with the updated or transformed elements. Collection processing is a crucial and frequently used feature of any programming language, and the Kotlin standard library provides a host of extension functions that can be used with collection objects to perform a variety of operations on its elements. Kotlin provides these operations in a functional programming style, and as a result, the resulting code syntax is concise. You will learn more about this when you learn how to define operations on collections in a later video. In this video, you learned about the importance of collection processing and some examples of common operations that can be applied to elements in a collection. In addition, you also covered the steps to define operations on collections. In this video, you will learn about generic classes and how they are used in Kotlin. Kotlin is a statically typed language, meaning it infers variable types at compile time. The code you've written so far had predefined type variables such as string, integer, and boolean, or it had a user-defined type such as class and interface. Let's say that you're developing a food ordering app. First, you implement a list of restaurants, and then you implement a list of menu items. However, the logic of the two lists is similar in nature. Duplicating your list code would be considered bad practice. This is where generic classes are useful. Generics uses type parameters to reuse the same set of code with different types. The type parameter refers to the type of object that will be passed and used with generics. For instance, a list T could represent a list with parameterized type T, and this can later be used in code with any type. A list of strings could be used as list string. Let's examine what a generic class is and how to use it. Let's say you have a class named item that takes an argument of a generic parameter type T, which is stored in value. You can create an instance of this class by providing the type, such as int, and passing in a value of that type, for example 10. Alternatively, you can create the instance without specifying the type, as the value passed is inferred automatically by the compiler. That is how you can use this class with a string as well as with an integer. Both print statements would print true, as the first item is an integer, while the second one is a string. A generic class is implemented just like a non-generic class. The only difference lies in the additional parameter type that is passed to the generic class. You can define a generic interface in the same way you define a generic class. In earlier examples in this video, you saw that you can pass almost any parameterized type to a generic class. However, this may not always be desirable, as you may need to restrict a generic class to accept only certain parameterized types. This can be done by using generic constraints. A common constraint type is an upper bound. This means you can enforce only upper bounds to be accepted, which inherit a pre-specified parent class. For example, let's say you have a sealed class named coffee and two subtypes called latte and cappuccino. You can restrict a generic class to only accept a parameter of type coffee. Then create an object of this class as val item equal to item coffee.latte. This compiles because latte is a type of coffee. However, if you try to initialize the object item with hello, it will show an error and will not compile because a value of type coffee is required, and a string is not a type of coffee. Now, let's discuss the advantages of generics in Kotlin. There are 3 advantages of generics in Kotlin. Type safety. Generics provide type safety by storing only objects of the parameterized type. Compile time checking. The parameterized types are inferred when the code is compiled. This helps to avoid issues from occurring when the code is running. And no need for typecasting. There is no need to typecast the objects. The compiler generates the required code to replace the parameterized type with the inferred types. In this video, you learned what generic classes and parameterized types are. You also learned how generics can help to perform operations on different data types. Finally, you examined the main advantages of using generics in Kotlin. In the later lessons, you will learn how to implement generic classes and functions. In this video, you will discover how, just as with classes, you can use generics with functions. Functions can be defined with type parameters, which are placed before the name of the function. Let's say in your family restaurant Little Lemon, you have an ordering kiosk where a customer can order a list of food items such as salads, mains, desserts, beverages, and so forth. If adding a food item to an order at the kiosk was to be written as a function in code, it would be represented by something like add food item to cart, where T represents a food item and the function gets called whenever a customer selects an item to add to the cart. Then specify the argument type while calling the generic function right after its name. In this case, for salad, beverage, and dessert. In the same way you use generic constraints with classes, you can also use them with functions. To understand this, let's examine an issue that may arise with a function that we have defined. Currently, the type parameter t is unbounded, which means that the function will accept an argument of any type. For instance, if we call the method with a string, the code will still compile successfully. This can lead to issues at runtime. The solution is to constrain the function to only accept arguments of type food item, which is a parent of items such as salad, beverage, dessert, and so forth. Following this approach, the function can be rewritten as fun t : food item, add food item to cart, item : t : list t. Now that you know how generics work, let's consider the limitations of generics. First is the issue of type erasure. While using generics, the type safety in Kotlin is checked at compile time, and at runtime, the instances of generic types have no information about the type of actual arguments used with generics. This is called type erasure. For instance, at compile time, list salad can be differentiated from list beverage, but at runtime this information is erased and the runtime only knows that the lists exist but has no other information on whether the list is of type salad or beverage. The lists get converted to a list of nullable any. The asterisk symbol is called star projection. It is used to represent the case when no information about the type argument is known, but type safety still needs to be ensured. It guarantees that every concrete implementation of the generic type will be a subtype of that projection. Another limitation involves type checks and casts. Because of type erasure, it is not possible to check if an instance was created with certain type arguments at runtime. As a result, the compiler does not allow checks to infer whether an instance is of a particular type or not. For example, if you have an integer list as a list of integers, its type cannot be checked for being list string. However, to deal with this, the compiler creates generic type checks to ensure that type safety and casts convert the arguments to their appropriate type based on the information known at compile time. Finally is the issue of unchecked casts. Type casts to generic types with arguments cannot be confirmed at runtime. In this case, unchecked casts can be written given that the program logic implies type safety. This is critical as any mistake while defining the type will lead to runtime issues. Take, for instance, the conversion of an object to a list of integers with an unchecked cast. Since the compiler cannot ensure type safety, it will create and display a warning. You have now learned about generic functions and how to use type parameters with them. You also explored the limitations of using generics and how to deal with them cautiously. Well done! You've reached the end of this week, where you explored the advanced object-oriented features of code development. Let's take a few moments to review what you've learned. To briefly outline what you covered this week, you had a recap on collections and their importance in programming. You learned about using generic classes to solve a problem, as well as how type parameters and type arguments are handled. You explored generic functions and how they are used to solve problems. That content brought you to many new places in your coding journey. Here are a few of the highlights that you may recall. A collection in Kotlin is used to represent a group of related objects or elements that can be referenced as a single unit, perhaps using a variable. Collections are an important concept in programming, as nearly every software application requires a variety of collections. There are several types of collections, such as lists, sets, maps, and more, which you covered in course readings. Kotlin allows you to access elements in a collection independent of the exact type of objects or elements stored in a collection. This is achieved using the collection interface, which is inherited by all subtypes of collections, such as lists, sets, and maps. This interface is responsible for defining the operations that all collection types must provide, regardless of their own specific characteristics and behavior. Going into more detail about generics, you learned that generics use type parameters to reuse the same set of code with different types. You also learned that type parameter refers to the type of object that will be passed and used with generics. Then you learned that the only difference between implementing a generic class and a non-generic class lies in the additional parameter type that is passed to the generic class, and that you can define a generic interface in the same way you define a generic class. Generic functions demonstrated that just as with classes, you can use generics with functions. Functions can be defined with type parameters, which are placed before the name of the function. This section concluded with an example based on Little Lemon Restaurant's food ordering function. That's the end of the summary and the end of this week, where you explored advanced object-oriented features. Well done, you covered a lot of new material, so be sure to take some time to practice those new concepts. Hopefully, you are looking forward to studying some more new areas of development next week. Previously, you learned how to declare an object and assign a value to it. The value assigned was typically a number or a text. In Kotlin, you can also create objects that can have a function assigned as their value. In this video, you will explore the idea that functions can be used as objects, how this can be useful, and how its implementation corresponds with a core principle of functional programming. There are several criteria that determine what good code is, and these include how concise and efficient the code is, how well it uses resources such as memory and device abilities, and it takes into account the code readability and maintainability. Consider the code you've written so far, and you will find that there are different ways of organizing classes and the relationships between classes in a project. For instance, you may inherit one class from another or use them as compositions. Ultimately, a single class will not function properly until all its dependency classes are provided. Therefore, any change to any item in a class can require a significant amount of work refactoring the code. Treating functions as objects takes a different approach. A function as an object is one of the core principles of functional programming. Functional programming is a programming paradigm that utilizes creating functions for clean, consistent, and maintainable code. While Kotlin is an object-oriented programming language, it does provide tools to support a functional programming paradigm as well. These tools, such as working with functions as objects, allow you to effectively combine the best of these two paradigms to create the most efficient code. Let's imagine you're building the menu functionality of the Little Lemon food ordering app. You need to get the list of menu items and display the received menu items on a screen. Class A will be responsible for getting the list of the menu items in its load menu items function. After receiving the result, it executes the display menu items function from class B and passes the items to it. With this code, you need to have an instance of class B to call the display menu items function after loading the list. This approach creates a tight coupling as class A holds a reference to class B. It is aware of the whole class and all of its aspects, such as its variables and other functions. In resource terms, this is known as overhead, since only the display menu items function is needed for correct behavior. Such overhead can be avoided by passing only the display menu items function itself as an object. Storing a function as an object is useful when it needs to be executed from a different class. This lets you replace the dependency on a whole class with a dependency on just a single function that you need. The code is not bound directly to classes, and this lets you effectively refactor, replace, or mock the implementation. Using a function as an object is a powerful tool that lets you separate the code blocks and execute a function from different parts of the code without tight coupling. It is an effective approach when you need a function to be executed from a different class. This is one of the fundamentals of functional programming. Try using it in your code and judge for yourself how it can improve the performance, readability, and maintainability of the code you write. In a previous video, you learned about the function type and how to define it as an object. Now you will learn how to define Lambda as an object and explore its practical use in coding. During this video, I'll explain how a Lambda expression is a simple way to define a function as an object. In the Little Lemon food ordering app, let's say that you must calculate a tax on the order cost. To calculate the tax, you multiply the price by the tax percentage. Defining a function object would be a good way to build the tax calculation, and you can use a Lambda expression to define a function as an object. To achieve that, inside the class scope of the main activity, you declare a variable called tax calculator as a type of function. A type of function is a combination of the data type of the parameter, which is written inside parentheses followed by the symbols hyphen, right angle bracket, and the return data type. Data type inside parentheses will refer to parameters that should be passed when executing this function. Similar to regular functions, there may be multiple parameters as well as no parameters at all. In this example, the function will require a double parameter to be passed, and the return value's type also will be double. The double is separated by a comma, and the return type will be double after that variable equals what is going to need to be done inside the function. To achieve that, you use curly braces, and inside these curly braces, you need to give names for the function's parameters. You should consider that the first parameter name you write will have the same type as the first type you provided during the declaration of the function type. Similarly, for the second parameter, it will have the same type as the second type in the declaration. For this example, there are two parameters. One is price, and the second one is tax ratio, followed by the symbols hyphen, right angle bracket. Then, the last step is to write the operation as a calculation of that price multiplied by the percent ratio. To test that lambda expression, call it inside onCreate the method, just as you call regular functions. Pass the cost of the order and the ratio. For instance, pass $200 and 6.5% to it, then assign its output to a variable called tax. To present it in the app, you can use a text widget. Now run the code to see the results. As you may know, Kotlin supports type inference, which means that instead of using function type declaration, you can declare the arguments inside the curly braces directly, but you must give them types. The lambda expression can be adjusted in this way by removing the function type, declaration type, and declaring the price and tax ratio as double. Running the adjusted code, it works as before. And that is how to use the lambda expression to define a function as an object. Now let's explore how to use the lambda expression as an extension function. For instance, you want to build the tax calculator expression as an extension function, since then you can use it along with any cost of any order or use it with any price that you want to calculate its tax. To begin with, you can add the double class name before the function declaration type. Instead of having two parameters, you will only have one, as you only need to know the ratio of the tax. Inside the curly braces, you have only one argument, which is the ratio. For the calculation part, you can use the this keyword to refer to the double value that uses that method, which in this example is the price, then multiplied by the ratio. Inside the onCreate method, use the price value and call the tax calculator method and pass the ratio 6.5% to it. Now run the code, and the output is confirmation again that you get the same result with this extension function approach to coding. This video demonstrated the use of a lambda expression by declaring it as a function object and as an extension function. Remember that you can declare it anywhere in your programming, and you should find that its use leads to more expressive and concise code. Let's say you're thirsty and you want to buy a soft drink. You're at a vending machine that accepts US dollars. The machine has 5 different flavors of soft drinks. You put in cash and press the appropriate button to choose your drink flavor. Then, as expected, the machine pops out the soft drink can with your choice of flavor. If you were to define this vending machine as a function in code, you would define the function with characteristics such as input parameters to be the amount of cash needed to buy a soft drink, specified in US dollars, and the choice of flavor. This function would then return an instance of a soft drink that represents the soft drink can of your desired flavor. Such equivalent notation of a function signature consisting of its parameters and return values is called a function type. But why do you use a function type? Let's say you are in a shopping mall that has several vending machines on each floor. This corresponds to the vending machine function being replicated at several locations in a mall. That is to say, there are multiple instances. Function types represent a function signature and can be instantiated to be stored as variables, passed as arguments, and so forth. Similar to a variable that belongs to any other data type. Let's examine how to define function types in code. The general structure of a function type includes a list of parameter types enclosed in a parenthesis followed by arrow notation, and finally its return type. For example, A and B are parameter types and C is the return type. Here are a few code examples of function types. The first example contains 2 parameters, the first one of type int and the second of type string, and the return type is a string. Function types can also have an empty parameter list, as represented in the second example that takes no parameters and returns a string. Function types may return unit, as represented by the third example that takes in an int and returns a unit. Function types can also have a receiver type, which restricts the type of objects that can invoke it. In the fourth example, the function type is restricted to being invoked only by objects of type string. The function types can also optionally contain the names for function parameters. Now, let's discover how to instantiate a function type. There are several ways to do this. Using a Lambda expression. A Lambda expression refers to passing the function implementation as an expression and is enclosed within curly braces. You will learn more about Lambda expressions in a later video. In an anonymous function, a code block can be defined. Using a callable reference that returns a function type value for an existing declaration of a function. For example, let's say you define a function multiply by 2 that takes in an int and returns an int by multiplying the argument value by 2. For a given list of numbers that you wish to print after multiplying all the elements by 2, you can acquire a function type instance for the function multiply by 2 as : multiply by 2. Alternatively, you can use an instance of a user-defined class that implements a function type as an interface. For example, you can have a class multiply by 2 that implements an interface with the function type int. You can then store the instance of the class as a variable. The last step to using function types is invoking the function type instances. An instance of function type, let's say f, can be invoked by using the invoke operator, as in f.invokex, or you can simply invoke it as fx. For example, an instance of a function type that adds 2 integers stored in a variable add integers function can be invoked in those 2 different ways. Printin add integers function or printin add integers function.invoke. In this video, you learned about function types in Kotlin. You discovered how to define function types and explored several ways you can use them in your code. A developer writes code that listens to touch events, and then an action based on those events takes place in the code. In this video, you will learn how to define and use such listeners using a Lambda expression. I'll demonstrate listeners in action with a simple XML user interface, or UI, and views. The UI contains one button that displays a toast when clicked. On the main activity, inside create method, declare a variable called button. I declare a variable called button, then get the button view by the findViewById method and pass to it the button ID which is in the XML. Use myButton variable to set a listener by using the settingsOnClickListener method, then passing to an object expression that extends from view.onClickListener view. OnClickListener is a listener to the click event of that button. In addition, OnClickListener is an interface, so it has an abstract method to override. Consequently, you need to override the onClick method inside that method as you are building a toast. Run the code, it should display a toast. Now let's define this listener using a Lambda expression, the onClick method. It takes one argument, which is view, and view will also be the argument of the Lambda expression. Define it by removing everything inside the parentheses, then use the curly braces within which you write the view parameter and infer as a view instance. Finally, you build the toast and run the code again. You might ask, what if you don't know what the parameters of the method of the listener that will be overridden are? To answer that question, let's add another component such as checkbox in our UI to listen to its changes. Add a checkbox to the UI, and in the main activity, you do a checkbox variable and get its view by the findViewById method. A listener for checked change is needed, but if you want to define it by the Lambda expression, the required parameters are unknown. In this case, you build it by object expression. Within the parentheses of the setOnCheckedChanged method, you use an object which is extended from compound_button.onCheckedChangeListener, and you need to override its abstract method, which is the onCheckedChanged method. You may notice that Android Studio shows a warning. Move your cursors to the warning. A message pops up stating to use the Lambda expression. Take the option to convert to Lambda expression. After Android Studio has converted it into Lambda expression, the parameters' names are P0 and P1. This is nothing to worry about. If you point your cursor to the parameter, it displays a pop-up stating that the parameter is value of which type. For example, if you point to P1, it states that parameter is a value of Boolean. Let's complete the code. Each time the checkbox is changed, it states from checked to unchecked. You want to display a toast, therefore you build a toast that displays what the state of the checkbox is by displaying P1 parameter. Run the code. The toast is displayed every time the checkbox state changes. That was a brief walkthrough of how to define a listener by using a Lambda expression. In addition, I demonstrated how Android Studio helps you to define a Lambda expression. Kotlin is a programming language that supports both object-oriented and functional programming paradigms. As you learned earlier, this allows you to use a function in the same manner as regular objects. That is, pass them as function arguments, store them in collections, and so on. This video introduces you to the concept and practice of higher-order functions. A higher-order function is a function that has other functions as its parameter or return value. A regular function usually has arguments of string, integer, or any other custom type. Having a function or a lambda as an argument of another function allows you to delegate a part of its responsibilities to the argument function. Therefore, the scope of tasks handled by a single function is reduced. Also, this enables you to customize the use case of each function execution without overloading it with if-else or when statements. Let's see in a real-life example how it can be useful. Imagine that you are building an employee paycheck feature for the Little Lemon restaurant. The paycheck operation will consist of multiple steps. First, the amount to be paid should be calculated by multiplying the hourly rate of an employee and the number of hours worked. Then the correct taxation logic should be implemented. This will take into account multiple factors, such as is an employee tax-free or not, freelance or a regular worker, what is the employee's tax rate, and many more factors. Implementing these functionalities strictly following object-oriented programming patterns can lead to code that is too wordy and requires lots of boilerplate to enhance it. Let's see how higher-order functions can be advantageous in such cases. The function for calculation should be able to calculate the paycheck amount based on hourly rate and hours worked. In addition, you should apply tax to that amount, considering many factors mentioned earlier. The typical schema for this operation would look like this, when every existing employee class would execute calculate paycheck function and pass all the required arguments. Moving the taxation logic into a separate function and passing it to calculate paycheck as an argument will convert the calculated paycheck into the higher order function. With this approach, the tax calculation can be customized for each individual employee. It can be implemented as reusable Lambda expressions that can be assigned to specific employees. This is an example of a higher order function with a function argument. In the same manner, you may return a function as a result of executing another function. For example, you can declare a higher order function for each employee class with a return value that provides taxation logic. In this video, you explored a high order function and discovered how it lets you define a function as a parameter to be executed inside a function. Higher order function is a very useful concept in Android development. It lets you define a function as a parameter to be executed inside a function. Let's explore how the high order function is defined. For example, you have a UI that contains a button, and each time the button is clicked, it displays a toast. Let's begin by building the UI. Create a function called simpleUI, which is annotated by composable. Inside the function, create a button. Inside the parenthesis, you need to pass a function to the onClick argument. If you try to build toast here, you'll find that you can't, as you need a reference to the activity the toast belongs to. So the solution is that you need to define a function as a parameter of the simpleUI function. That parameter can be called as onClick as a function type, and that function type has no parameter or return type. To do that, declare the onClick parameter inside the simpleUI methods parenthesis, followed by a colon, then type empty parentheses, followed by the symbols dash right angle bracket, followed by unit data type, which means that the function has nothing to return. Inside the button parenthesis, assign the onClick parameter that is created to the onClick argument of the button. Inside the setContent method that is created in the onCreate method, the simpleUI method can be called, since there is only a function as an argument. The parentheses can be changed to curly braces, and within those you can build a toast that states a button has been clicked. Run the code, click the button, and the output is a toast that states that button is clicked. Let's do some adjustments to the example to count how many times the button is clicked and display the number. First, declare a variable inside the simple UI, which can be called as count as int type and assign 0 to it. Then edit the onClicks parameter to accept an integer number by typing int inside its parenthesis. Next, in the button parenthesis, instead of assigning it directly to the onClick argument of the button, type curly braces and include the onClick parameter to be executed and pass to its argument count++. That is, to be increased each time the button is clicked. Finally, in setContent method, where the simple UI method is called, the Android Studio display inside the curly braces refers to the click counts. Now you can edit the toast content to display the count. Run the code again, and each time the button is clicked, the count is increased and displayed in a toast. To summarize what you learned in this video, you explored how to define a high-order function and discovered how it lets you define a function as a parameter to be executed inside a function. You're spending a lot of time studying and practicing your software development. Let's say you're planning to take a break and watch a movie at a nearby cinema. In this case, you would generally search for the movie you're interested in watching and then filter the show listings based on your time preferences. Then, let's say you decide to buy 2 adult tickets and 1 child ticket. If you observe carefully, you will realize that you performed various operations on different collections and their elements. For example, for a given movie, to select a show, you filter the list of available shows based on your show timing preferences. Once a show is selected and the tickets are added to a cart, the system calculates the total amount by executing a sum operation on all the elements of a collection that represents the list of tickets. Similarly, you would generally come across several scenarios in your daily life when certain operations on elements of a collection are applied. In this video, you're going to learn about the idea behind collection processing, explore a few examples of collection processing, and examine the steps involved in it. Firstly, let's address what collection processing is. Collection processing refers to applying certain operations on some or all the elements in a collection. Let's say you are analysing the order history of the restaurant Little Lemon for the past week. You have a collection with each element as a list of orders for a specific day. Now let's say you wish to have a look at the orders for Wednesday. You would apply a filter operation to the collection with its value set as Wednesday. Now that you have the list of orders for Wednesday, let's say you wish to apply a sorting operation so that you can see the list of orders in the descending order of the order amount. For this, you would apply the sort descending operation on the collection of orders. Lastly, let's say you wish to calculate the total amount of all the orders that were placed on that day. For this, you'd run an operation that would aggregate and sum the amount of each order to return the total amount. That's an example of collections in action. You just implemented 3 different operations on collections. You applied a filter operation to filter the list of orders by a specific day, followed by a sort descending operation to arrange the orders in the descending order of order amount, and then finally a sum operation to calculate the total amount of orders on that day. A few other common examples of collection processing include sorting courier deliveries based on postal or zip code, finding the average of a list of numbers, grouping together a list of sub-items to form another list, splitting a list of numbers into 2 lists, one for odd numbers and another for even numbers. Collection processing involves 3 primary steps: accessing elements of a collection on which the operation is to be applied, defining and applying the operation on the element, and outputting a modified collection with the updated or transformed elements. Collection processing is a crucial and frequently used feature of any programming language, and the Kotlin standard library provides a host of extension functions that can be used with collection objects to perform a variety of operations on its elements. Kotlin provides these operations in a functional programming style, and as a result, the resulting code syntax is concise. You will learn more about this when you learn how to define operations on collections in a later video. In this video, you learned about the importance of collection processing and some examples of common operations that can be applied to elements in a collection. In addition, you also covered the steps to define operations on collections. In programming, you often use collections, and sometimes you want to perform an operation on every item in these collections. This is where for each is of use. The Little Lemon restaurant wants to apply a 20% discount to their entire menu. All the food items are already stored in a list of menu item data classes. Let's see how you can achieve this using for each. To begin, start with a class called menu. Menu has a list of menu items and each item has a name and a price. The iteration loop is Kotlin's for-each function. For-each is a higher order extension function applied to arrays and iterables. For-each takes an action Lambda argument with one input, iterates over all elements and executes the action for each one. Now you implement print discounted menu, which applies a discount and prints out the result. Print discounted menu iterates over the menu items using for-each. The for-each Lambda argument creates a copy of each menu item with a discounted price. Deduct the discount from the whole, then multiply the original price by the result. The copy of each menu item is then printed out. Through main, you instantiate menu and call print discounted menu with 0.2 for a 20% discount. When you run the code, the output will be a list of menu items with the discount applied. For-each is an excellent example of an extension function and of a higher order function. It enriches a collection with the powerful capability to perform an operation on its every element. It also helps us avoid repeating ourselves, leading to code that is more maintainable and less error-prone. Instead of applying a discount to every menu item individually, the Little Lemon restaurant can now be assured that any new menu items will automatically be discounted without having to change their discount function. A common scenario in programming is when you have a collection and you want to produce a list of elements based on that collection. The new list can be of elements of the same type or of a different type entirely. Imagine having a list of employees and wanting to extract a list of only their names. This would be an excellent candidate for the map function. The Little Lemon restaurant wants to print their menu without the prices shown. They have a list of all food items as menu item data classes. Using map, you will extract the menu items without prices and create the new menu. Map is a higher order extension function that is a part of the Kotlin standard library. It is available for all array types as well as iterables. Map takes a transformation lambda as an input. It applies this function to every element and returns a list of the transformed outputs. Start with menu, a class with a list of menu items. Each item has a specific name and a price. You then add the getMenuItemNames expression function, which iterates over the menu items using map. The map lambda argument returns a single value for each menu item. In this case, it returns just the name of each menu item as the Little Lemon restaurant required. In main, you then instantiate menu and print the result of getMenuItemNames. Finally, when you run the code, you see a list of menu item names without their prices. As you've learned in this video, when you want to transform a collection of elements to a list of elements, you use map. In our example, Little Lemon transformed a list of menu items with prices into a list of menu items with just the names and no prices. It is common for your collection to contain elements that you are not interested in. However, the opposite is also true. You may only be interested in some of the elements in your collection. When you only want the list of elements you care for, you use filter. The Little Lemon restaurant is due to have a health inspection. They need to provide a list of dishes that have certain allergens in them. They already have a list of every dish on their menu, so all that is left is to extract the relevant dishes. Filter is a higher order extension function on all array types and iterables. It is part of the Kotlin standard library. Given a predicate lambda, filter iterates over every element and returns a list of only those elements for which the predicate is true. To make sure the Little Lemon restaurant passes their upcoming health inspection, they introduced a health and safety course for new employees. To know who to invite to the course, they have a list of all their employees, but they need the list of just the new employees. The Little Lemon restaurant also needs to be able to provide a list of dishes containing certain allergens, and they have a list of all their dishes at the ready. There is a set of employees, and each employee has a name and a work starting date. To know who to invite to the new course, you need to filter the list of employees to return only those that started working after the 1st of April 2022. You are given a set of dishes, with each dish having a name and a list of ingredients. For the health inspectors to examine relevant dishes, you need to filter out dishes by a given ingredient. The Little Lemon restaurant has an address book of all its current employees. Every employee is recorded with a name and the day from which they started working, formatted by year, month, day with 0 padding. This format makes comparing dates easier. To filter the employees by their starting date, implement the new employees function. This function takes a start date. It then calls filter to return only employees whose hiring date is greater than or equal to the provided date. Now, to provide Little Lemon with the list of employees they requested, you call new employees with the required date. When you run the code, you should see that Bob and Amanda are returned. Both joined the company on or after April 1st, 2022. Now to the next challenge in Little Lemon's recipe book. Each dish has a name and a set of ingredients, and you want to obtain a list of all the dishes that contain a certain ingredient. Add the dishes with ingredient function. Dishes with ingredient filters the dishes set by executing contains on the ingredients of every dish. Only positive or true results are returned. To test dishes with ingredient, instantiate recipe book and call dishes with ingredient with flour as an input. Running the code, you should see only fish and chips and onion rings listed, since these are the only dishes containing flour. Filtering collections using a predicate to obtain a subset of the collection is quite a common requirement. You should now know how to use the filter extension function to meet that requirement. There are moments when you may need to aggregate elements from your collection into a single representation. Kotlin provides you with many functions to achieve this, including map and filter, already explored in this course. These functions have specific purposes, and sometimes you need a more generic solution. For example, you may want to aggregate the elements of a collection into a set. Another example can be wanting to use a string builder to construct a string for the elements. Fold is a Kotlin extension function that will help you in these scenarios. The Little Lemon restaurant is doing an inventory check, and they need a list of all the ingredients in their dishes. Each ingredient must only appear once in the list, to avoid any duplication when they go to order ingredients from their suppliers. Before stocking up with fresh ingredients, the Little Lemon also needs to know if they can afford the order. They need to add today's order's income to their balance to know their budget. Fold is a higher order extension function on all array types and iterables. It is part of the Kotlin standard library. Fold takes an initial value and an operation Lambda. Fold iterates over all elements, calling the operation Lambda once for each, passing in the accumulator returned from the previous operation. For the first execution, the accumulator is the initial value provided to Fold. Finally, the accumulator is returned. To help Little Lemon create the list of all ingredients used in their dishes, you will use Fold over their dishes, accumulating the ingredients in a set of strings. For Little Lemon's second requirement, the budget check, you will use Fold to add their current balance and their income from today's orders. You have seen Little Lemon's recipe book earlier. It holds a list of all the dishes. Every dish holds a set of its ingredients. To return a unique set of ingredients, implement the All Ingredients function. This function leverages Fold by passing in a mutable set of strings as the initial value and adding the ingredients of every dish in the dishes list to that mutable set. To generate the output Little Lemon requested, instantiate recipe book and call All Ingredients on it. Run the code and observe that all ingredients are present and appear just once. To help Little Lemon find its current balance, start with balance. Balance is a class that takes one constructor argument with the initial balance. Extend balance by adding the balance after orders function. This function takes a collection of double values representing the income from recent orders. It then calls Fold to start with balance and then increment it by the value of each order. Finally, it returns the accumulated value. Little Lemon's balance before today's orders was 140. Instantiate balance with this value. Their orders today were for $20, $15, and a final one for $30.50. You can call balance after orders with a list of these values. Now run main. You should see Little Lemon's new balance of 140 plus 20 plus 15 plus 30.50, giving 205.50. Fold is a very powerful function. You can use it to determine sums, construct strings, or find aggregated values. Kotlin has simpler functions to achieve some of these goals, but knowing how to use Fold gives you flexibility where these other simpler functions are less capable. Here I used Fold to give Little Lemon a list of all ingredients used in their dishes, with each ingredient appearing once only. In addition, I demonstrated how Fold can be used to calculate Little Lemon's current balance. Previously, you learned about some common collection functions, such as for each, map, filter, and fold. While these functions work well independently, their strength is multiplied when they are used together. For example, imagine having a list of cars. How would you extract the name of each car model that was first sold after the year 2010? Calling a filter to obtain the relevant models and then a map to extract their names would be a clean solution. Let's examine how a similar approach can be used when the Little Lemon restaurant needs to hire new chefs. In the restaurant business, they refer to the main meals that a diner can order as a dish. For instance, lasagna is a dish, as are margherita pizza and mushroom risotto. To help the new chefs get started, you are asked to find dishes that have no more than 3 ingredients and list them by their name and the number of ingredients they contain. You are also asked to update Little Lemon's address book, marking all existing employees as veterans and then adding the new chefs. Finally, you are asked to output the list of employees and whether they are veterans. Kotlin's collection processing functions operate on a target collection and return the result collection. The properties of these functions mean that the functions are designed to be chained or called one after the other. Each function operates on the output of the previous one. To find the dishes with the fewest ingredients, you would start by filtering the dishes, keeping just those with no more than 3 ingredients. Then map the dishes to strings of dish names and the number of ingredients. To update Little Lemon's address book, first map the current employees to mark them as veterans. Then use fold to add the new chefs to the existing employees. Lastly, use map again to generate a list of employee names and veteran statuses. Here is Little Lemon's recipe book again. It holds a list of all the dishes. Every dish holds a set of its ingredients. This example includes orange juice. The place to start is by declaring the Easy Dishes function. This function takes the maximum number of ingredients as input. It then filters the list of dishes by comparing the size of each ingredient set against the maximum number provided. Each filtered dish is then passed to the map function to be converted to a string of the dish name and the size of its ingredient set. To get the dishes with no more than 3 ingredients that Little Lemon requested, you instantiate recipe book and call Easy Dishes on it, passing in 3 as the maximum number of ingredients. The result is printed out by passing it to print in. When the code is run, only dishes with 3 or fewer ingredients are returned, with the appropriate ingredient count for each. Next, let's help Little Lemon obtain an updated list of employees. Their address book holds the names, and Is Veteran field was added for each employee. Initially, none of the employees are veterans. To deliver the requested list of employees, you would start by adding the Print with New Employees function. It takes a list of new employees as an input. It then calls map to replace every existing employee with an updated copy with the veteran flag set to true. Then it calls fold, passing in the new employees list, made mutable using toMutableList as the initial value. The fold action is to add each existing employee to this new mutable list. Finally, it uses for each to iterate all employees and print out the name and veteran status of each. You would need to instantiate address book and call print with new employees on the new instance. Then run main to see a list of the names of all employees, old and new, printed out with their veteran status. That's a demonstration of how Kotlin's collection processing functions operate on a target collection and return the result collection. With both of the Little Lemon examples, the properties of these functions allow the functions to be called one after the other, with each function operating on the output of the previous one. Well done! You've reached the end of this week, and it was all about items related to functional programming. Let's take a few moments to review what you've learned. In Kotlin, you can also create objects that can have a function assigned as their value. This is an effective approach when you need a function to be executed from a different class. It can improve the performance, readability, and maintainability of your code. In this video, you learned about function types in Kotlin. You discovered how to define function types and explored several ways you can use them in your code. Function types represent a function signature and can be instantiated to be stored as variables, passed as arguments, and so forth. The function types can also optionally contain the names for function parameters. A higher order function is a function that has other functions as its parameter or return value. Having a function or a lambda as an argument of another function allows you to delegate a part of its responsibilities to the argument function. It can be implemented as a reusable lambda expression. A major area of learning this week was the collection processing functions. You learned about the importance of collection processing and explored some examples of common operations that can be applied to elements in a collection. You also covered the steps to define operations on collections. After this, you learned about for each and how it is defined and used in real life. You also learned about defining higher-order extension functions. Next up was map, enabling you to create lists of elements based on collections. You specifically covered how to create a new menu for the Little Lemon restaurant without including the cost of the menu items. You then learned about defining and using filter, used when you only want to focus on a particular list of elements from a specific collection. As you approach the end of the week, you covered fold, a Kotlin extension that allows you to aggregate elements from your collection into a singleton representation. And lastly, you learned about using collection functions together. This highlighted how the individual processing functions are stronger when used together. That's the end of your study for this week, where you covered many new areas of advanced programming in Kotlin and Android. Well done. You've reached the end of this advanced programming in Kotlin course. Well done. You've come a long way, learned new skills, added more tools to your development toolbox, and expanded your understanding of the Kotlin programming language. Take a moment to congratulate yourself. After all, you've learned a lot in this course. The end of course graded assessment is a development project where you will get a chance to apply what you've learned. This includes integrating Kotlin and Android, using advanced object-oriented features, and implementing functional programming. But before you embark on the final assessment, let's reflect on the key learning milestones you've reached. You began this course with an examination of Android and Kotlin in the real world, and you covered the steps to set up an Android project in Kotlin. The major new learning area for you in week 2 concerned object declarations. You specifically learned about object declarations, as well as constant values and activities with arguments. You discovered the concept called singleton, where you create only one instance of a class. To do this in Kotlin, you can use an object declaration. And finally, you learned how to implement constant values and functions with arguments in companion objects. You then explored the advanced object-oriented features of code development. Major items you covered here included using an extension function to add a method to a class, exploring test-driven development, including its methodology and main features, discovering the purpose and types of testing and implementing a unit test, employing mocks and fakes for unit testing in Android, and defining and using a generic class. You learned what extension functions are, why you need them, and what their limitations are. You use extension functions whenever you have to extend the functionalities of a class or an interface in an external or a third-party library that you cannot inherit from or modify. Testing was a major topic to cover, and you should now know why testing is an essential part of software development. It ensures your software works as expected. Testing comes in two main types, functional testing and non-functional testing. Several advantages of a test-driven development were mentioned, including you write minimal code with the intent of passing all the defined tests, your code is highly tested and has a high test coverage, and it is easier to maintain and refactor code. However, there are certain dangers with test-driven development, or TDD. These include simply writing unit tests alone is not sufficient in this environment. Following TDD strictly may require an excessive amount of testing time. False positives may arrive when developers incorrectly assume expected outcomes, and the practice of TDD can be hard to adapt to. You covered collections in Kotlin. A collection in Kotlin is used to represent a group of related objects or elements that can be referenced as a single unit, perhaps using a variable. Kotlin allows you to access elements in a collection, independent of the exact type of objects or elements stored in a collection. This is achieved using the collection interface, which is inherited by all subtypes of collections, such as lists, sets, or maps. Generics have particular advantages in Kotlin, including type safety, compile time checking, and no need for typecasting. In the following week, you learned about using a Lambda expression. A Lambda expression refers to passing the function implementation as an expression and is enclosed within curly braces. In week 3, you learned about using a Lambda expression. A Lambda expression refers to passing the function implementation as an expression and is enclosed within curly braces. You then moved on to higher order functions. A higher order function is a function that has other functions as its parameter or return value. Having a function or a lambda as an argument of another function allows you to delegate a part of its responsibilities to the argument function. Therefore, the scope of tasks handled by a single function is reduced. Also, this enables you to customize the use case of each function execution without overloading it with if-else or when statements. Lastly, you learned about the collection processing functions. Collection processing involves 3 primary steps: accessing elements of a collection on which the operation is to be applied, defining and applying the operation on the element, and outputting a modified collection with the updated or transformed elements. You learned about the importance of collection processing and explored some examples of common operations that can be applied to elements in a collection. As an example of collection processing in action, you implemented different operations on their own and as part of multi-step collection processing. That included defining and using for each, map, filter, and fold. You've reached the end of this course recap. It's now time for you to proceed to the last part of your course and try out what you've learned in the graded assessment. Good luck with that final practical app project for the Little Lemon restaurant. Congratulations on reaching the end of this Advanced Programming in Kotlin course in the Android Developer Professional Certificate track. You've worked hard to get here and developed a lot of new skills along the way. You're making great progress towards developing great Android apps. You should now understand how to use more advanced Kotlin programming features, including object declarations, advanced object-oriented features, and functional programming. The key skills measured in the final graded assessment revealed your ability to demonstrate knowledge of object declarations in Kotlin, utilize advanced object-oriented features such as extensions, testing and collections, and generics, and exhibit knowledge of functional programming such as Lambda expressions, higher order functions, and collections processing. So, what are the next steps? This advanced Kotlin programming course has enhanced your development knowledge and skills in several key areas. You probably realize that there's still more for you to learn. So, if you found this course helpful and want to discover more, then why not register for another course and continue your learning journey? You'll continue to develop your skill set during each of the Android developer courses. Whether you're just starting out as a programming professional, a student, or a business user, the course end projects prove your knowledge of the value and capabilities of Android. And once you've completed all courses in this program, you'll receive a certification in Android development. The certification can also be used as a progression to other role-based certifications. Depending on your goals, you may choose to go deep with advanced role-based certifications or take other fundamental courses once you earn this certification. These certifications provide globally recognized and industry-endorsed evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.